Welcome to your first chemistry video. There's going to be a lot of these throughout the year, which will help with instruction and help you with notes. Hopefully understand, please pause, take your time with these, and you can come back before test and review. But this is how we're going to do notes throughout the year. So this is the first one. And this, please make sure you have your, when you watch this video, make sure you have your physical and chemical changes properties worksheet with you. To follow along, I'll basically be going through to fill this out with you. Again, pause if you need to, rewind. This video is always going to be up on Google Classroom, so you can get to it at any time. So make sure you have this out. Go ahead and pause the video if you need to come get this. But we're going to start with what is a physical change? So a physical change is a change that do not change So essentially it is a change that does not change the chemical identity of the substance. So how do we know when there is a physical Basically, physical change is it's still the same substance. Like if I cut this paper in half, well, it's still paper. So the chemical composition is still the same. So it is a change where a substance is the same chemically. So this would, the hardest one is phase changes, where if we take water and we boil it and it turns to steam, well, that steam is still water, it's still H2O, still the same properties. And if we freeze water and it becomes solid, well, it's still just water and ice. So physical changes are all physical changes. That's the hardest one to remember, so we're going to try to remember phase changes are still just physical changes. So what is the chemical change? Well, if a physical does not change the chemical identity, chemical changes do. So it is a change in chemical identity. How do we know when there's a chemical change? Well, a new substance is formed. So we're going to practice together here. So, perfume evaporating on your skin. Remember how I said phase changes? So we know evaporating is a phase change, so that is a physical change. Butter melting is also a phase change, so that is P. Wood rotting. What do you notice about wood rotting? Okay, well, for chemical changes, why don't we remember these 6 changes to kind of think that they're possible. So I've gone ahead and listed those 6 changes. So odor, a change in odor can indicate a chemical change. A change in color. Gas produced, again, we need to be careful because if I boil water, we do see a gas, but that is a phase change and not a product of gas. So this is without heating. Light, if light is produced. Thermal change, of course, that's heating or cooling. In a precipitate, this is not precipitation, this is a precipitate. This is when we see this much later on, a lot of examples where we have 2 liquids and also in a solid forms. And we'll talk more about precipitate as the year goes on. Okay, so when we look at wood rotting, well, there's going to be a color change and an odor change with wood rotting. So that is going to be an indication that it's chemical. Charcoal cooking your food. Well, we know from that the charcoal does not look the same, so there's a color change. We also notice there's an odor of burning. So we're going to, there's also a light and thermal change, so that's a lot. So we're going to say that's definitely chemical. Glass cracking. Well, it's still glass, so that is a physical change. Melting again, phase change, so that is physical. Burning sugar, if you burn sugar, you know you get some light, you get some thermal change, you get color, you get odor, so that is chemical. Digestion food, this is also going to be chemical. Copper tarnishing, that is a color change, and that is chemical. Boiling again is a phase change, so that is physical. Coloring white paper purple, so if I was to draw with my purple marker, well, on stove paper, so that is a, even though it's a color, we would expect that if I do this. Same as if I add food coloring to water, yeah, it's a color change, but it's not really a color change. It's just red water with food coloring. So this is physical. Crumpling a piece of paper, stove paper. Freezing again, there's that phase change. Mothballs gradually vaporizing in a closet. Okay, mothballs vaporizing is a phase change, so that is T. This is after sublimation, goes from solid directly into gas, and we'll talk more about sublimation later throughout the year. And exploding fireworks, well, we definitely get color change, we get light, we get thermal, so that's going to be chemical. Hydrofluoric acid attacks the glass to etch it, that is a chemical. Photosynthesis, hopefully you learned that from biology, is a chemical process. And chlorine gas liquefies at negative 35 degrees Celsius, that is a phase change, so that is P. Okay, you can review, pause, come back, look anything up, and ask questions when you come back to school. Okay, we're going to move on to the next part of this, which is over here. So we're going to start right here. Okay, so for 6 here, we're going to list each change and find whether it's a physical or chemical change. So first, I want to highlight what those changes are. So to burn magnesium, the student must cut. So there we go, we got cut. We have light, a Bunsen burner. We have bending the magnesium to hold it. We have pass the strip over the flame to ignite the magnesium. So ignite the magnesium. And so right now we have 1, 2, 3, 4, and a white light is produced. Okay, so let's take each one. So we're going to look at cut. So cut a magnesium strip is, well, cut, it's still magnesium. So at this point we have not done anything to that. So we're going to say cut Mg is a physical change. Light a Bunsen burner. So that is going to be chemical, because again, burning, flame, light. Okay, holding the strip of magnesium, so bending. That is physical, it's still magnesium. Ignite. Magnesium is chemical, and then light produced is also chemical. Okay, again, have this written down. I will go ahead and highlight those pieces if you have a highlighter, or underline them. Make sure you have that list, and pause if you need to, and rewind. Okay, we're going to go ahead and fill out the chart. Okay, back here, I've already filled this out, so go ahead and pause the video and fill this out. Just point out that there is actually only one chemical probability on this list, and that's flammability. So we're going to look at these next three columns together. And probably new vocabulary word is going to be intensive or extensive. And as we look through this list, we're going to ask our question, does it change with the amount? Okay, so that's going to be the key thing here, the definition of what is intensive and extensive. So first we're going to fill this, and then we'll follow that, okay? So go ahead and pause the video. Again, to save time, I'm going to fill this out now, and then okay, so go ahead and fill this out now, pause the video. I've also put a little thing here. I'm going to come back to that, but if you want to go ahead and write that down, that'll be a real helpful thing, because this intensive and extensive property is going to carry throughout the whole complete school year in chemistry. So we're going to take a look. So I've already filled out, does it change with the amount? So if we look at melting point, it doesn't matter how much I have, that substance melts at the same time. That is going to be a intensive property. Okay, and then if we look at density, also does not change, so that is also an intensive property. Specific heat does not change, so intensive. Hopefully you're starting to pick up the pattern here. So here's our first change, area. We know if I add or take away of something of the substance, the area changes. Well, this is a extensive property if it changes, and that's why I have this down here. Try to remember mass. It's going to keep coming up. You're going to see it on test. Mass, which is just mass, area, length, volume, and shape, are actually the only extensive properties there are. Everything else is intensive. Okay, so if you look at malleability, that is no, so that is intensive. Also ductile is intensive. Mass, again, changes, so that is extensive. Flammability does not, so that's intensive. Again, no, intensive, intensive. And flammability, gasoline is going to burn if I got a drop or a whole bunch of it. And boiling point is also does not change, so that's intensive, intensive, and then extensive. So go back to this question. Well, if it can change based on the amount, can you determine that substance? No. So intensive properties can help you identify, extensive cannot. So real quick, we'll run these down. There we go. Since that's intensive, yes. I'm going to go intensive, yes. Intensive, yes. Extensive, no. Intensive, yes. Yes. No. Yes. 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 No. Okay. So that should be all filled out. Again, pause it if you need to, but we're going to go ahead and move on to the next part. Okay. So we're going to use the reading here to answer questions here. So, one, if you have 43.2 grams of an unknown substance, is this information enough to identify the unknown substance? No, just because that's mass, right? That goes back to that extensive property. So we're going to go no, and because it's extensive. Again, mass is an extensive property, so just all that tells me is the mass of it. It could be anything. You have 22.04 milliliters of an unknown substance. Again, no, because same reason above, that is extensive property. I could have anything that volume. The unknown substance has a melting point of 115.2 degrees Celsius. That would be yes. And what's the reason? Hopefully you remember that it is intensive, so yes. If you found the melting point, you can go to Google and find melting point is this, and it'll tell you what substance it is. Density. Density is also intensive. even though it has two, comes from mass and volume that are extensive, remember it's that ratio, and ratio stays the same. Water is density of 1. Doesn't matter if I have an ocean full of it or a little glass full of it. Yes. And intensive. Okay, I went ahead and filled this out. So you can pause it now and copy this information down. You should have figured out that it was sulfur because of this and that. If you look at sulfur, density is 1.96 grams, and its melting point is 115.2. You can see that's different from argon and from carbon. So you can kind of get this, and we've already talked about intensive properties are reliable for identification. Also, please watch this. You can see a question on the test where we're really making sure you understand density does not change. Density is all the same. Okay, so please watch that and make sure you understand that fully. Then it doesn't matter if I go from 43.2 grams to 10.8, density is still 1.96. Okay, so what I want you to do now is answer this last page, practice what we've learned, and come and check your answers in class. Okay? But work this out on yourself to see if you've gotten that first part. I hope you enjoyed the first video, and many to come.